Alright, this is the final unit of the Introduction to Chemical Energetics, and what we're going to cover today is the other method of calculating energy change, which is the experimental method. In last video lessons, we talked about two ways of measuring energy change. One is a theoretical method, by which we calculate the energy needed to break bonds and sum it with the energy released by bond forming, and we take the difference between the two to see how much energy is released or how much energy is absorbed in an overall reaction. And this unit, we're going to talk about the experimental method in which we measure and calculate energy change experimentally. And the method to do this is calorimetry, which is the science, here we go, which is the science of studying the change of heat during a reaction. Now, in order to use this experimental method, we need what we call a calorimeter, which is simply, in our class, which is a simple styrofoam cup, where we have the water solution inside the water cup, and the styrofoam cup will act as an insulator. And the reaction is going to happen inside here, and you stick a thermometer into it, and you will record the energy change. And what you also measure is the volume of water used, and as well as the amount of reagents that you put into the reaction. Okay? So once you put your reagents in there, you have it into a solution, and the reaction goes on, and then you stick a thermometer back into it, you record the before, the temperature before the reaction started, and temperature after the reaction has occurred, and then you take the difference, and then you have your temperature change. Now, the styrofoam cup, not all reactions will happen inside water solutions or a styrofoam cup. You may want to measure the heat released when you burn something. And this is where you can have an optional fire source. Now, the fire source can be like if you want to burn methane or hydrogen or propane, which is safer, or paraffin oil, whatever you have, right? You can burn in, have an optional fire source. But if you have an optional fire source, you can't really use an insulator as your container, because insulators do not really transfer heat well. So you need a good heat conductor as your container. For example, a copper container, okay? So there you go, a basic setup of a calorimeter. Right, so for calorimetry, what we need is, usually for our class, we use water as the agent to measure the energy change. So when we do a reaction, we put something in there, and then we want to see the energy that's released or absorbed by the substance. We will use water as our agent in order to see how much energy is absorbed by the water or released by the water to the surroundings in the reaction vessel. Okay, so let's get started right away. Dive right down into it. So to measure energy change, again, energy change is simply enthalpy change, which is now we use the formula MCAT. MCAT is the formula needed to calculate the energy change. M stands for mass of whatever substance that we're going to use. In this case is water for our class. C is the specific heat capacity, which is the specific heat capacity of water, the amount of energy or heat required to increase 1 gram of water by 1 degree centigrade. And delta T is the change of temperature. So let's take an example. We have 0.5 grams of copper 2 sulfate, and we add them to water in 5 milliliters of water, okay? And so we want to know how much energy has changed, because now copper 2 sulfate is now, anhydrous copper sulfate has now become has dissolved into water solution, thereby maybe releasing or taking energy from the water solution. Alright, so after we conducted the experiment, you notice that the temperature has increased by 4 centigrade. Alright? Okay, so we'll take all this information and plug them in. The mass of water is 5 grams because we use 5 milliliters of water. The density of water is 1, so therefore 5 milliliters of water becomes 5 grams. The specific heat capacity of water is 4.2 joules per gram centigrade, and this number is something that you need to memorize, but the specific heat capacities of other stuff out there is different, so you only don't have to memorize all the specific heat numbers except for water. Alright, so it's good to know that. And the temperature change we measured was about 4 degrees centigrade. So you plug that into your MCAT formula. You have 5 times 4.2 times 4, you get 84 joules. So this little reaction that you have, or the dissolving of copper to solvent into water, you have released 84 joules of energy. Okay, so the temperature went up. But how much energy is released per gram of copper to sulfate? Because we only use 0.5. Well, multiply 84 by 2 and you get 168. So that is the amount of energy released by 1 gram of copper to sulfate. But the question may ask you, how much energy is released per mole of copper to sulfate? Well, that is the mole enthalpy change. And so you need to figure out the relative formula mass of copper to sulfate, which is 160 grams per mole. You multiply 160 by 168 joules per gram by 160 grams per mole, and then you get 26.9 kilojoules per mole. So if you reacted or dissolve 1 mole of copper to sulfate into water, you would release 26.9 kilojoules of energy. So that is the basic method of using a calorimeter to measure energy change. And in class, you're gonna do a research on the presentation of the production of energy, and then we'll go on to the next unit.